Hello children. So in this video we'll do the third sum. The third sum of exercise 2.2 polynomials. The problem given to you is 6x squared minus 3 minus 7x. You're asked to find the zeros of this following quadratic polynomial. Should verify the relationship between the zeros and the coefficients. How do you find the zero? You should find that value of x for which this polynomial is equal to 0. So first let us arrange the polynomial in the order of the powers of the variable. 6x squared minus 7x minus 3 is equal to 0. This is the standard form of the polynomial. This is how you write a quadratic polynomial. Ax squared plus bx plus c is equal to 0. So we have written it, and now in order to find the zeros, let us split the middle term in such a way that the sum, we have to split the middle term into two numbers such a way that the sum is equal to minus 7 and the product of those two numbers is equal to 6 multiplied by minus 3 AC, and I am talking about A into C, is equal to minus 18. So let's find factors of minus 18. Factors of minus 18 which add up to minus 7. So 18 and 1 is your first factor, and it has to have, one of the numbers has to have a negative sign. The sum of 18 and 1 will never be 7. So these factors are ruled out. Let's go to the next factor. I think 9 multiplied by 2. Yes. And it is not negative 18. Let me put minus 9 into 2. Yes, it's negative 18. And if you add minus 9 plus 2, you get minus 7. So this factors, these two numbers, minus 9 and 2, satisfies our search for our two numbers, adding up to minus 7 and multiplying to minus 18. So 6x squared minus 7x is split and written as minus 9x plus 2x minus 3 is equal to 0. Now let's group them. Group these. This is one group and this is two group, and take out the common factors from each group. In the first group, if you see, 6 and 9 are multiples of 3. So 3 is a common factor and x is a common factor. So the remaining is 2x minus 3. Okay. And yes, in your second group, it is plus 1 into 2x minus 3 is equal to 0. Now in these two terms, you see that 2x minus 3 is common to both the terms. So 2x minus 3 into 3x plus 1 is equal to 0. These are the factors. These two are the factors of your quadratic polynomial 6x squared minus 7x minus 3. Now what are the zeros of this polynomial? The zeros are where 2x minus 3 is equal to 0 and 3x plus 1 is equal to 0. So what are the values of x at these zeros? Here it's 2x is equal to 3 or x is equal to 3 by 2. In this case, it's 3x is equal to minus 1. I hope I'm right. Yes, 3x is equal to minus 1 or x is equal to minus 1 by 3. Now, we have to verify the relationship between the zeros and the coefficients. So, let's see how we go about it. We know that the sum of the roots should add up to, like suppose we assume that alpha and beta are the roots of this equation. So alpha plus beta should be equal to minus b by a, the coefficient of x by the coefficient of x squared. In this case, our first root is 3 by 2 plus minus 1 by 3, which is minus 1 by 3. So let's see whether they add up to minus b by a. Now 3 to 6 is the LCM. 3 3 is 9, minus 1 into 2, 2. So this is equal to 7 by 6. So, and yes, the coefficient of x is 7. It's a negative 7, but it's a negative 7. And the coefficient of x squared is 6. So 7 by 6 and you can write this as minus of minus 7 by 6, right? Isn't it? This can be written as minus of minus 7 by 6. So, we have verified that alpha plus beta is equal to minus b by a. Now, for our next the roots, the product of the roots, yes, alpha beta. Alpha beta should be equal to c by a. What is our alpha and beta? 3 by 2. Let's multiply and see. 3 by 2 into minus 1 by 3 gives us minus half, isn't it? 3, the 3 gets cancelled. And what are our c by a? What is our coefficient? So c is minus 3, isn't it? And a is 6. So c by a is equal to minus 3 by 6, which is equal to minus half. So this condition is also verified. So these two conditions, these two relationships between the roots and the coefficients are verified and they are found to be correct. So this means that our roots are also correct. So I hope you followed. Thank you.